Okay, I'm going to run through an example of Kruskals algorithm from chapter 3 of the D1 book. Okay, so we're going to look at this network here. As you can see, there are weights on the edges that I've drawn in, and I've also copied down here the set of vertices, okay, which I'm going to fill in as I go. But the first thing to do with Kruskals algorithm, and this is the one to do with edges, remember, that we write the edges in order of weight. Okay, so the edge with the least weight is AB, or I could have written AE, it doesn't matter which. Okay, so AB, and in brackets I'm going to write the weight. So the next one on this list will be AE. It doesn't matter if I write it EA. Okay, it means exactly the same thing. It would only matter if the edges had direction. I also now have, I've got DE. Okay, so that's at 3. And next up is, say, AF. Okay, there's also BC there, I can see, with 4. So I'll have that next, BC. Okay, so that leaves me with DF. EF at 6. AC at 7. And AD at 8. Okay, so how this works is I look through my list starting from the very top, and I choose each edge in turn unless choosing that edge would create a cycle. And I wouldn't go on choosing edges if all of my vertices are connected. So the first one I'm going to look at is AB, 2. Okay, so that's the first one I'm going to have. Ooh, change that. Put it on the straight line. That would be a better idea. Okay, so I'm first going to have AB. Okay, so I will now circle that one because I'm having that one. Okay, now I'm going to look at AE. Including AE would not create a cycle, so that's the next one I'm going to have. Okay, so I'm going to circle AE. Now I'm going to look at DE. I can see that that won't create a cycle either, so I continue. Okay, and I will have that one, so I circle it. Ooh. Next up is AF. Okay, I can just quickly check my graph here to see if there's no cycles, and I can see there won't be, so I will have AF. Next on my list is BC. Okay. And that is it. Okay, so I know I can now stop because all of the vertices are connected by a tree, a minimum spanning tree in this case. Okay, so the last thing you need to do once you've done that is add up your totals of the edges. Okay, so we have 2 plus 2 plus 3 plus 4 plus 4. Okay, so that's 2, 4, 5, 6, 7, 11, 15. So the minimum spanning tree has a value of 15.